March 17, 1945, 2,000 feet above the Autobahn near Koblenz, Germany. 19-year-old Second Lieutenant Robert Bobby Cowan's hands are sweating inside his flight gloves. His P-47 Thunderbolt shudders as he banks into his attack run, 8 5-inch rockets loaded under the wings. Below, a German convoy trucks, half-tracks, fuel tankers stretches for nearly a mile. His squadron leader's voice crackles in his headset. "Steady, wait for my mark." But Cowan's thumb slips on the throttle. It brushes the rocket release. All 8 rockets fire simultaneously, 2,000 feet too early, a full 3 seconds before the proper release point. He watches in horror as the rockets streak downward, certain he's just wasted his entire load. Then the lead truck explodes, and the next. Within 15 seconds, the entire convoy is burning. What should have been a career-ending mistake has just become the most devastating single attack of his squadron's combat record. By early 1945, the war in Europe had reached a critical phase. Allied armies were advancing across Germany, but their advance depended entirely on supply lines that stretched hundreds of miles. Every gallon of fuel, every round of ammunition, every replacement part had to be transported from rear depots to the front lines. The Germans faced the same challenge, except their supply situation was desperate. Allied bombing had crippled German railways. Oil refineries were destroyed. Manufacturing centers were rubble. The Wehrmacht's mechanized forces, tanks, trucks, artillery were running on fumes. Their only hope of moving supplies was road convoys, traveling at night or during bad weather when Allied aircraft couldn't find them. But by 1945, Allied fighter bombers were everywhere. P-47 Thunderbolts, Hawker Typhoons, P-51 Mustangs, all equipped with a devastating new weapon, high-velocity aircraft rockets, or HVARs. These 5-inch rockets carrying 45-pound warheads could penetrate tank armor or obliterate trucks with a single hit. 8 rockets per aircraft, 4 aircraft per flight, 32 rockets that could destroy an entire convoy in a single pass. The pilots flying these missions were remarkably young. The experienced veterans of 1940-43 had completed their tour or been killed. Their replacements were teenagers, many just 18 or 19 years old, fresh from training schools, thrust into combat with perhaps 200 hours of total flight time. They'd trained on rockets for maybe 10 hours. Most had never seen combat until their first mission over Germany. Second Lieutenant Robert Cowan was one of these teenagers. Born in 1926 in rural Pennsylvania, he'd enlisted at 17, finished flight training at 18, and arrived at his squadron, the 365th Fighter Group, the Hell Hawks, in February 1945. He'd flown exactly 4 combat missions before March 17th. 4 missions, 80 hours of combat time. He was still figuring out how to work his radio properly. But here's where it gets interesting. Youth and inexperience sometimes created unexpected advantages. Older pilots with more experience had also developed more caution. They'd seen friends die. They understood risks intimately. Young pilots like Cowan had something else. They didn't fully comprehend how dangerous their missions were. The bravery that comes from not quite understanding you can die. Rocket attacks required precise execution. The attacking pilot would dive toward the target from 3,400 feet, building speed to avoid ground fire. At 2,000 feet, he'd level off briefly, aim using a crude gun sight that required mental calculation of trajectory and lead angle. At 1,500 feet, he'd fire his rockets, watching them streak forward on pillars of white smoke. Then he'd pull up hard, climbing away while the rockets completed their trajectory to the target. The timing was critical. Fire too early and the rockets would fall short or overshoot. Fire too late and you'd be too low to escape ground fire after pulling up. The pickle point, the moment you pressed the rocket release, had to be precise. Veteran pilots could feel it instinctively. Teenagers like Cowan were still learning. Training emphasized this precision. Flight instructors drilled rocket attacks repeatedly. 2,000 feet, level flight, steady aim, pickle, pull up. But training happened over empty ranges in the American Southwest, where nothing shot back and mistakes meant embarrassment, not death. Combat over Germany was different. Mistakes meant dying or wasting expensive ammunition or watching German convoys escape to kill Allied soldiers tomorrow. The 365th Fighter Group had been flying ground attack missions since D-Day. They destroyed hundreds of locomotives, thousands of vehicles, countless German positions. Their tactics were refined through hard experience, but every mission brought new pilots replacing those killed or wounded. The squadron flew 6 days a week, weather permitting. Each mission meant 4 to 6 hours of intense stress. Takeoff, navigation to the target area, hunting for enemy convoys, the attack run through defensive fire, navigation home, landing with battle damage. Stay with me because this next part is crucial. The rockets themselves were dangerous even when everything went right. The 5-inch HVAR used a solid fuel motor that burned for 1 second, accelerating the rocket to over 1,000 feet per second. But the motor was temperamental. Sometimes rockets would hang, fail to release even when fired. A hung rocket with a burning motor was a bomb strapped to your wing. Sometimes rockets would fire asymmetrically, left side but not right, sending the aircraft into an uncontrollable spin. Sometimes the warhead would explode prematurely, destroying the aircraft that fired it. Pilots learned to fear their own weapons as much as German flak. Every rocket attack meant trusting that 8 explosive devices, mounted inches from your fuel tanks, would behave properly. Young pilots like Cowan didn't have the experience to recognize when something felt wrong. They just followed procedures and hoped. March 17, 1945 started as a routine mission. The weather was poor, low clouds, rain, typical March conditions over Germany. The squadron briefing identified a suspected German convoy moving south toward the Rhine, trying to evacuate equipment before Allied forces cut them off. Intelligence suggested 30-40 vehicles, possibly including fuel trucks and ammunition transporters. High-value targets. 8 P-47s launched from their base in France, Cowan flying as wingman to Captain James Mitchell, a veteran with 43 missions. The formation flew northeast, staying under the cloud deck at 3,000 feet, following roads and railways toward the suspected convoy location. German flak was sporadic. Most anti-aircraft guns had been destroyed or evacuated. But that made the remaining guns more dangerous. Pilots couldn't predict where fire would come from. At 14:25 hours, Mitchell spotted the convoy on the Autobahn near Koblenz. A long line of vehicles moving slowly, exposed on the open road. Perfect targets. Mitchell's radio call was calm, professional. "Tally-ho, convoy on the highway, 12 o'clock, 2 miles. Line abreast formation, I'll take the lead vehicles. Cowan, you're on the rear. Remember your training. Wait for 2,000 feet. Don't rush it." Cowan acknowledged, his voice tight with tension. This would be his first rocket attack on a convoy. He'd fired rockets before at trains and isolated vehicles, but never at a target this valuable or this well-defended. His hands gripped the control stick, palms slick with sweat despite the cold at altitude. Now, to understand how this impossible accident happened, we need to go back and understand the problem these rocket weapons were designed to solve. To understand why 19-year-old Bobby Cowan was flying a rocket-armed fighter over Germany in March 1945, we need to go back to 1943, when the Allied air forces faced a problem that traditional weapons couldn't solve. The problem was targets that wouldn't die. Allied fighters and bombers had proven effective against buildings, railways, and concentrations of troops. But German armored vehicles, tanks, half-tracks, armored cars were incredibly resilient. A .50 caliber machine gun bullet fired from a strafing fighter would bounce off tank armor. Even direct hits did minimal damage. Bombs worked if you scored a direct hit, but hitting a moving 15-foot-long tank from 5,000 feet was nearly impossible. German convoys exploited this invulnerability. They moved supplies by road, knowing that Allied aircraft could strafe them but couldn't reliably destroy heavy vehicles. Yes, fuel trucks and cargo trucks were vulnerable, but the escorts, armored vehicles with anti-aircraft guns, would survive most attacks and continue protecting the convoy. The Germans developed tactics. Space vehicles far apart to limit damage, move during bad weather, use wooded roads for cover, position flak guns at intervals. The strategic implications were serious. Every German convoy that reached the front lines meant enemy forces could continue fighting. Every tank that escaped destruction would kill Allied soldiers. Intelligence estimated that German road convoys were moving thousands of tons of supplies monthly despite Allied air superiority. Something had to change. Traditional weapons had clear limitations. Machine gun fire required multiple passes to destroy even soft-skinned vehicles, and each pass exposed the attacking aircraft to ground fire. Bombs were inaccurate. Hitting a convoy required dive bombing, which was dangerous and allowed most vehicles to escape. The .50 caliber M2 machine guns carried by American fighters were excellent weapons, but they weren't designed to penetrate armor. The British faced this problem first. Their Hawker Typhoons flew ground attack missions over France, hunting German armor and vehicles. Pilots reported frustration. They'd attack panzer columns, expend all ammunition, and watch most tanks continue moving. RAF Fighter Command needed a weapon that could destroy armor reliably from a single pass, without requiring the attacking aircraft to expose itself for extended periods. The solution seemed obvious: rockets. The British had developed the RP-3 rocket, a 3-inch rocket with a 60-pound warhead that could penetrate tank armor. Typhoons could carry 8 RP-3s, giving them enormous destructive power. The rockets weren't particularly accurate, but against large targets like convoys, accuracy mattered less than sheer firepower. American military observers watched British rocket attacks with great interest. The results were impressive when they worked, entire German columns destroyed in minutes. But the RP-3 had problems. It was heavy, reducing aircraft performance. It was awkward to install and arm, and most critically, it was inaccurate at ranges beyond 1,000 yards. British pilots had to attack from dangerously low altitudes to hit targets reliably. The U.S. Army Air Forces wanted their own rocket weapon, but one that addressed the British system's limitations. The requirement went to the Navy's Bureau of Ordnance and the California Institute of Technology, which had been developing rockets for various applications. The specification was demanding: destroy a tank with a single hit, accurate to 1,000 yards, light enough not to significantly affect aircraft performance, simple enough for field arming and maintenance. What emerged was the 5-inch high-velocity aircraft rocket, the HVAR, though pilots called it the Holy Moses for the devastation it caused. The design was elegant: a 5-inch diameter rocket motor burning for 1 second, accelerating a 140-pound package to over 1,000 feet per second. The warhead contained 45 pounds of high explosive, enough to penetrate tank armor or destroy a truck outright. But here's what made the HVAR revolutionary. It was designed as a system, not just a weapon. The rockets came preloaded in launch rails that mounted under aircraft wings. Arming required flipping 2 switches, no complex procedures. Aiming used a modified gun sight with additional ranging marks. The entire system was designed so a young pilot with minimal training could employ it effectively. The stakes of getting this right were immense. By late 1943, the Allied invasion of France was being planned. That invasion would require absolute air superiority and the ability to destroy German armored reserves before they reached the beaches. If German panzer divisions could counterattack the landing forces, the invasion might fail. Rocket-armed fighters could prevent that if the weapons worked, if pilots could use them effectively, if the entire system could be deployed before D-Day. Time pressure was intense. The HVAR program received urgent priority in early 1944. Manufacturing had to be scaled up from prototype to thousands of rockets monthly. Aircraft had to be modified to carry the launch rails. Pilots had to be trained. Tactics had to be developed. All of this had to happen in months, not years. The human element added another layer of complexity. The pilots who would employ these weapons were increasingly young and inexperienced. The veteran pilots of 1942-43 were rotating home after completing combat tour. Their replacements came straight from training command, 18- and 19-year-old kids who'd learned to fly in Texas or Arizona, who'd never been shot at, who'd never seen anyone die. These young pilots would be asked to fly single-seat fighters deep into enemy territory, find heavily defended convoys, attack through intense ground fire, and employ a brand-new weapon system they'd barely trained with. The margin for error was razor-thin. Make a mistake with conventional weapons and you waste ammunition. Make a mistake with rockets and you might kill yourself or let a critical target escape. But the solution would come from an unexpected place, and it would transform these teenagers into some of the most effective tank killers in military history. Enter Dr. Charles Lauritsen, a Danish-born physicist at the California Institute of Technology, who would design the weapon that gave teenagers the power to destroy armored columns. Lauritsen wasn't a military man. He was a scientist who'd spent the 1930s studying nuclear physics and cosmic rays. But when war came, Caltech's physicists turned their expertise toward weapons development. Lauritsen's team was assigned to rocket research, working under contracts from the Navy's Bureau of Ordnance. Their mission: create aircraft rockets that actually worked. The challenge was more complex than it appeared. Rockets had existed for centuries, but reliable, accurate rockets were rare. The fundamental problem was stability. A rocket had to fly straight despite having a motor that pushed from the rear while the warhead's weight pulled from the front. Any imbalance would send the rocket tumbling. British RP-3 rockets partially solved this with large fins, but that created drag and limited range. Lauritsen's team approached the problem systematically. They studied every aspect: propellant chemistry, motor design, fin configuration, warhead shape, ignition systems. Each component was tested individually, then integrated, then tested again. The work was painstaking and unglamorous, more mathematics and materials science than anything resembling combat. The breakthrough came from understanding spin stabilization. Artillery shells were stabilized by rifling that made them spin. Lauritsen realized that rocket motors could be designed with slightly angled exhaust nozzles that would induce spin as the rocket flew. This gyroscopic stability would keep the rocket straight without requiring large, drag-inducing fins. The 5-inch diameter was chosen deliberately. It was large enough to carry a substantial warhead, but small enough that aircraft could carry multiple rounds without excessive weight penalty. The motor used a solid propellant, simpler and safer than liquid fuels. The warhead was a shaped charge designed to penetrate armor through focused explosive energy. But here's where things got interesting. The launch system was as important as the rocket itself. Previous aircraft rockets used complex launchers that required careful alignment and electrical firing circuits prone to failure. Lauritsen's team designed a simple rail launcher, essentially a metal tube that guided the rocket for the first few feet of flight. The rocket sat in the rail, held by simple clips. When fired, an electrical impulse ignited the motor. The rocket accelerated along the rail and the clips released it. No complex mechanisms, nothing to jam or misalign. The electrical system was equally simple. 2 wires ran from the cockpit firing button to each rocket. Press the button, current flows, igniters fire. The system could fire rockets individually, in pairs, or in salvos. This gave pilots tactical flexibility. Fire all 8 at once for maximum shock effect, or fire pairs over multiple passes to conserve ammunition. Testing began in late 1943 at the Naval Air Station at Inyokern, California, a desolate desert location perfect for weapons testing. Test pilots flew modified aircraft over the Mojave Desert, firing prototype rockets at mock targets. The early tests revealed numerous problems. The first problem was rocket bloom. When multiple rockets fired simultaneously, their exhaust plumes interfered with each other, degrading accuracy. The solution was to stagger the rockets slightly on the wings so their exhaust wouldn't interact. This simple spacing change improved accuracy dramatically. The second problem was more dangerous: electrical interference. The rocket motor's ignition created electromagnetic pulses that sometimes triggered adjacent rockets prematurely. Several test aircraft nearly crashed when rockets fired unexpectedly. The fix required shielding the electrical wiring and adding time delays between firings when using salvo mode. The third problem was pilot technique. Test pilots discovered that the HVAR behaved differently than bullets or bombs. Bullets traveled in nearly straight lines at close range. Bombs fell in predictable arcs. Rockets followed complex trajectories, initially straight, then gradually curving downward as the motor burned out. Pilots had to learn to aim not where the target was, but where it would be when the rocket arrived. Training methods were developed rapidly. Pilots practiced on ground ranges, firing at targets marked with range poles to help judge distance. Gun camera footage from practice missions was analyzed to help pilots understand their aiming errors. Experienced pilots developed rules of thumb. Fire at 1,500 feet, aim 1 target length ahead, rockets will hit in 2 seconds. The physical installation on aircraft required modifications. P-47 Thunderbolts and P-51 Mustangs received triple-rail launchers under each wing. 3 rockets per rail, 6 rails total, 18 rockets possible, though typically only 8 were carried for weight and drag reasons. The launch rails were stressed to handle the rocket motor's thrust without flexing, which would throw off accuracy. Arming procedures were carefully designed for safety. The rockets arrived at forward bases with their warheads and motors separated. Armament crews would install the motors in the launch rails, then screw the warheads onto the motors. Only after the aircraft was ready for takeoff would the electrical connections be made, arming the firing circuit. Even then, the pilot had to flip a safety switch in the cockpit before the firing button would work. By spring 1944, the HVAR system was ready for combat deployment. Over 100,000 rockets had been manufactured. Thousands of launch rails had been installed on aircraft. Training programs were producing pilots who understood the weapon's employment. The entire system, Rockets, launchers, training, tactics had been developed in barely 18 months. But here's what nobody fully appreciated. They'd created a weapon system so powerful that it would fundamentally change ground attack warfare. A single fighter armed with 8 HVARs could destroy an entire tank platoon in one pass. A squadron of 12 aircraft could obliterate a German armored column. The sheer destructive power available to individual pilots was unprecedented. And they were giving this power to teenagers. 18 and 19-year-old pilots who'd never been in combat, who trained on these weapons for perhaps 10 hours, who would be expected to employ them accurately while flying at 300 mph through enemy fire. The weapons worked beautifully in testing. Whether they'd work in combat, operated by terrified young men making life-and-death decisions in seconds, remained to be seen. The first HVAR-equipped squadrons deployed to England in May 1944, just weeks before D-Day. The 365th Fighter Group, the unit Bobby Cowan would eventually join, was among them. Their orders were clear: hunt German armor, destroy enemy convoys, prevent reinforcements from reaching the invasion beaches. The success of the entire invasion might depend on whether these untested weapons and inexperienced pilots could execute their mission. Initial combat reports were mixed. Some attacks were devastatingly successful, entire German columns destroyed. Others were failures, rockets missing by wide margins, hitting friendly forces, or failing to fire at all. The learning curve was steep and paid in lives. Pilots who survived their first few missions learned. Those who made mistakes often didn't get a second chance. However, what happened during the first test flights would shock everyone involved and reveal that the greatest danger wasn't the enemy, but the weapons themselves. The first combat-configured P-47 Thunderbolt carrying 8 HVARs took to the skies over England on April 12, 1944, and immediately revealed problems nobody had anticipated in testing. Captain William "Bill" Dunham, a veteran pilot with the 365th Fighter Group, was chosen for the evaluation flight. He'd flown over 30 combat missions in P-47s and was known for his precise flying and detailed debriefing reports. If anyone could identify issues with the new weapon system, it was Dunham. The flight plan was straightforward: take off, climb to 10,000 feet, fly to a designated practice range over the English countryside, execute several simulated attack runs, return to base. No live firing. This was purely to evaluate how the rockets affected the aircraft's flight characteristics. The engineers wanted to know, how much did the weight and drag affect performance? Did the rockets create handling problems? Were there any unexpected issues? Dunham's takeoff was normal, though he immediately noticed the additional weight. The 8 rockets plus their launch rails added over 1,200 pounds, equivalent to carrying 2 additional pilots. The P-47's powerful R-2800 engine handled it, but acceleration was noticeably reduced. Climb rate decreased from 2,800 feet per minute to about 2,200 feet per minute, not crippling but significant. At altitude, Dunham began his evaluation. He rolled the aircraft left and right, testing aileron response. The rocket's weight, mounted far out on the wings, increased the aircraft's moment of inertia. Rolls were slightly slower, requiring more control input. Not dangerous, but something pilots would need to know. Then he pushed into a dive, simulating an attack run. This is where the problems began. At 350 mph, the rocket rails began vibrating, not violently, but enough to be felt through the control stick. At 400 mph, the vibration increased dramatically. The entire aircraft shook. Dunham immediately pulled out of the dive and radioed base, experiencing severe vibration at high speed, possibly dangerous. Back on the ground, engineers examined the aircraft. They'd anticipated some aerodynamic issues, but nothing like what Dunham reported. Wind tunnel testing hadn't revealed this problem because the tunnels couldn't replicate the complex airflow around a full-scale aircraft diving at combat speeds. The solution required redesigning the launch rail mounting brackets. The original design attached the rails directly to the wing hardpoints, but this allowed the rails to flex under aerodynamic load, creating vibration. The modified design added triangular bracing that stiffened the entire assembly. Testing confirmed this solved the vibration problem, but every aircraft already equipped with rails needed modification. Hundreds of man-hours of work before the squadrons could be declared combat-ready. While engineers solved the vibration issue, pilots discovered another problem during live-fire training missions over Welsh mountain ranges used as practice areas. Lieutenant Robert Morrison fired his first practice salvo on May 3, 1944. Following the prescribed procedure, he rolled into a dive at 3,000 feet, leveled at 2,000 feet, aimed at the target marker, a large white cross painted on a hillside, and pressed the firing button to launch 2 rockets. The rockets fired perfectly. Morrison watched them streak forward on pillars of white smoke. Then his aircraft yawed violently to the left. Morrison fought the controls, managing to level the wings and pull out of the attack run. Back at base, examination revealed the problem. One rocket had fired, the other had hung, failed to release from its rail despite the motor igniting. The burning rocket motor, producing thousands of pounds of thrust, had pushed the left wing forward while the right rocket's recoil pushed that wing backward. The asymmetric forces nearly sent Morrison into an uncontrollable spin. This was terrifying. If a rocket hung during combat, especially during a low-altitude attack when recovery time was minimal, the pilot would likely die. The investigation revealed that the clips holding rockets in the rails sometimes didn't release properly. Rocket motor thrust would normally push the rocket forward out of the rail, but if the clips stuck, the motor would burn while the rocket remained attached to the aircraft. The fix required redesigning the release clips and adding a redundant release mechanism. But this took time the invasion planners said they didn't have. D-Day was approaching. The solution was procedural. Pilots were instructed to fire rockets individually or in pairs, never in full salvos, to minimize asymmetric thrust if a rocket hung. Ground crews were given explicit instructions on clip installation and inspection. Meanwhile, tactical training revealed the human factor challenges. Young replacement pilots, fresh from stateside training, struggled with the complex calculations required for accurate rocket employment. Second Lieutenant James Fletcher, 19 years old, arrived at the 365th Fighter Group in early May 1944. He'd completed flight training in Texas with high marks, but he'd never fired a rocket until he reached England. His first practice mission was humbling. Fletcher rolled in on the practice target, steadied at 2,000 feet, aimed carefully using the special rocket sight markings, and fired. Both rockets missed by over 200 yards, impacting far beyond the target. His second pass was worse, the rockets fell short. His third pass was closer, but still missed. After landing, Fletcher was frustrated and embarrassed. "I don't understand," he told his flight instructor. "I'm doing everything they taught us." The instructor, Captain Harold Meyer, was patient but blunt. Training, range, and combat are different. Training, you had all the time in the world to set up your pass. Combat, you'll have 10 seconds from seeing the target to firing. Training, nobody was shooting at you. Combat, every second you're in that dive, people are trying to kill you. You'll be scared, your hands will shake, and you'll have to make split-second decisions. You need more practice. Fletcher flew practice missions daily for 2 weeks. Gradually, the movements became instinctive. Roll, dive, level, aim, fire, pull up. The rockets began hitting closer to the target, not perfect, but good enough. By late May, Fletcher was declared combat-ready. He'd fired perhaps 30 practice rockets total, roughly 4 hours of practice time. It wasn't much, but it was all the training time available. Other pilots struggled with different aspects. Some couldn't judge distances accurately, firing too early or too late. Some pulled up too aggressively after firing, causing the aircraft to stall at low altitude. Some forgot to arm the electrical firing circuit and discovered over the target that their weapons wouldn't fire. Each mistake in training was a lesson learned without consequence. The same mistake in combat meant death. The squadron developed practices to help. Experienced pilots flew as flight leaders, with rookies as wingmen. The leader would demonstrate the attack, then the wingman would follow, learning through observation. Gun camera footage from practice missions was reviewed in group sessions, with veteran pilots explaining what the younger pilots did wrong and how to correct it. Stay with me because this next part is crucial. The psychological preparation was as important as the technical training. Squadron commanders understood that asking teenagers to fly into intense ground fire required more than just teaching them how to aim. They needed confidence, belief that their aircraft could survive damage, that their tactics would work, that their training was adequate. Without that confidence, young pilots would hesitate at critical moments, or refuse to press attacks, or panic when things went wrong. Captain Meyer gave a briefing to new pilots that became famous in the squadron. "You're going to be scared. Everyone is scared. The pilots who survive are the ones who can think through their fear. When flak starts exploding around you, your instinct will be to pull out, abort the attack. Don't. Complete your run, fire your rockets, then get out. The Germans are scared too. They know if you hit them, they're dead. Your job is to be more determined than they are. By early June 1944, the squadrons were as ready as they could be. Hundreds of pilots had trained on HVARs. Thousands of rockets were stockpiled at forward bases. Tactics had been refined. Aircraft modifications were complete. The invasion of France was imminent, and rocket-armed fighters would play a crucial role. But the real test was coming. All the training, all the modifications, all the briefings would be tested against German defenses that had spent years perfecting their anti-aircraft tactics. The young pilots, some barely out of high school, would face the ultimate examination: combat, where mistakes weren't graded with bad marks but with death. But its real test was about to come in actual combat, and the first missions would prove both the weapon's devastating effectiveness and its deadly unpredictability. June 7, 1944, one day after D-Day, the 365th Fighter Group launched its first rocket-armed combat mission against German positions in Normandy. Captain Harold Meyer led 12 P-47 Thunderbolts, each carrying 8 HVARs, targeting German armored reserves attempting to reach the invasion beaches. Intelligence reported a panzer column moving through the Norman countryside near Caen, exactly the threat the rockets were designed to eliminate. At 800 hours, the formation crossed the channel at 8,000 feet. Below, the invasion fleet still crowded the beaches. Ahead, smoke from burning villages marked the front lines. Meyer's radio call was calm. "Eyes open. Watch for flak. We're hunting panthers." They found the German column at 8:35, moving through a tree-lined road, 8 Panther tanks, numerous half-tracks, and support vehicles. Perfect targets, but perfectly defended too. The Germans had positioned flak guns along the route, anticipating exactly this kind of attack. Meyer made his decision instantly. "Line astern formation. I'm going in first. Follow my lead, watch my rockets, adjust your aim accordingly." This was Doctrine. The leader attacks first, demonstrates the technique, draws defensive fire, while wingmen learn from his example and attack the distracted defenders. Meyer rolled into his dive from 6,000 feet. His P accelerated rapidly, the airspeed indicator climbing past 400 mph. German flak opened up immediately, orange tracers arcing upward, black smoke bursts from 88 guns. He ignored them, focused entirely on the lead Panther tank growing rapidly in his gun sight. At 2,000 feet, he leveled off. The tank filled his sight picture. Range 1,500 feet, closure rate 600 feet per second. He pressed the firing button. 2 rockets leaped from the rails, their motors igniting with brilliant white flame. 2 seconds later, they struck. The first rocket hit the Panther's turret, penetrating the armor and detonating inside. The tank's ammunition exploded, blowing the turret completely off the chassis. The second rocket struck a half-track behind it, obliterating the vehicle. Meyer pulled up hard, the G-forces graying his vision, climbing away as German flak chased him. His wingman, Lieutenant James Fletcher, the same nervous 19-year-old from training, followed immediately. Fletcher's attack was textbook perfect. He steadied at 2,000 feet, fired 2 rockets at the second Panther, pulled up. Both rockets struck, destroying the tank. Fletcher's hands shook from adrenaline, but he'd done it correctly. The remaining 10 pilots attacked in succession. Within 3 minutes, all 8 Panther tanks were destroyed or disabled. Half the convoy was burning. German troops abandoned their vehicles and fled into the woods. The attack had been devastatingly successful. But then tragedy demonstrated the weapon's dangers. Lieutenant David Morrison, making his first combat rocket attack, fired his salvo at a half-track. 1 rocket hung, its motor burning while stuck in the rail. The asymmetric thrust yawed Morrison's P-47 violently. At only 1,500 feet with insufficient altitude to recover, Morrison fought the controls desperately. The aircraft rolled inverted and crashed into a field. Morrison died instantly. The squadron returned to base with mixed emotions. 11 aircraft, 1 pilot lost. 8 tanks destroyed, a convoy wrecked. Success by any military measure, but Morrison's death shocked the young pilots. The rockets had proven their effectiveness, but also their danger. The weapon that gave them power to destroy tanks could kill them just as easily through mechanical failure. Captain Meyer's debriefing was somber. "Morrison did everything right. This wasn't pilot error, it was equipment failure. We need better quality control on those rockets." But privately, he knew the truth. In war, doing everything right wasn't always enough. Sometimes you died through bad luck, a defective part, or random chance. Over the next weeks, rocket-armed fighters flew hundreds of sorties. The learning curve was steep. Some attacks were spectacularly successful, others failed completely. Young pilots learned or died. This was just the beginning. What came next would cement the HVAR's legendary status and show these teenage pilots could master the deadliest weapon in tactical aviation. By August 1944, rocket-armed fighters had become the most feared weapon in the German Army's experience. The Normandy breakout was underway, and Allied fighter-bombers hunted German convoys with lethal efficiency. The 365th Fighter Group flew 6 missions daily during peak operations. Young pilots who'd been terrified novices in June were now hardened veterans by late summer. Those who survived their first 10 missions developed instincts that kept them alive and made them deadly. Lieutenant James Fletcher, the nervous 19-year-old from training, flew his 25th mission on August 12, 1944. By then, he destroyed 7 tanks, 12 trucks, and countless other vehicles. He no longer shook during attacks. The fear was still there, but controlled, channeled into sharp focus. He'd become what the Air Force needed, an efficient killer. The Falaise Pocket in mid-August demonstrated the HVAR's devastating effectiveness. Trapped German forces tried desperately to escape the Allied encirclement. Thousands of vehicles jammed the roads leading east, tanks, trucks, artillery, everything the Wehrmacht owned in Normandy. Allied fighter-bombers descended on this target-rich environment like wolves on sheep. Captain Harold Meyer led his flight over the pocket on August 18th. The scene below was apocalyptic. Miles of burning vehicles, exploding ammunition, fleeing soldiers. Meyer's flight attacked a column of tanks trying to break through. In 15 minutes, they destroyed 11 tanks with rocket fire. The Germans abandoned their vehicles and fled on foot. But here's where it gets interesting. The pilots were learning tactics that training had never taught them. Lieutenant Robert Morrison discovered that firing all 8 rockets simultaneously created a shotgun effect. Even if individual rockets missed, the sheer volume of explosions destroyed targets through blast effect and fragmentation. This worked perfectly against convoys where vehicles were closely spaced. Lieutenant Fletcher developed a different technique. Fire 2 rockets, observe where they hit, adjust aim, fire 2 more. This walking the fire approach was slower but more accurate against single targets like command vehicles or fuel trucks. Captain Meyer pioneered the daisy chain attack. The flight leader would attack from one direction, forcing German vehicles to disperse. Then wingmen would attack from different angles, catching the scattered vehicles as they fled. This tactic increased kills per mission dramatically. The psychological effect on German forces was profound. Survivors reported hearing the distinctive whistle of incoming rockets caused paralyzing terror. Many German units refused to move during daylight, knowing Allied fighters would find and destroy them. This immobility made them vulnerable to ground forces. Individual achievements were remarkable. Captain Meyer finished his tour with 34 confirmed vehicle kills, including 15 tanks. Lieutenant Fletcher destroyed 19 vehicles before being shot down over Germany in October. He survived and evaded. Lieutenant Morrison claimed 22 vehicle kills before completing his tour. But you won't believe what happened during the single most successful rocket attack of the war. September 2, 1944, Lieutenant Samuel Davis led 4 P-47s against a German column near Mons, Belgium. The Germans were evacuating a supply depot, over 100 vehicles including fuel trucks. Davis positioned his flight perfectly, attacking from different angles to prevent escape. The first pass destroyed the lead and rear vehicles, trapping the convoy. Subsequent passes targeted the fuel trucks. When those exploded, the fire spread rapidly through the closely packed column. Within 10 minutes, the entire convoy was burning. Post-strike reconnaissance confirmed 94 vehicles destroyed. 4 aircraft, 32 rockets, nearly 100 vehicles eliminated. The success came at a cost. The constant operations exhausted pilots physically and mentally. Flying 6-hour missions daily, facing ground fire repeatedly, watching friends die, it ground down even the strongest. The average combat life expectancy for rocket-armed fighter pilots was 14 missions. Many didn't survive that long. Yet these teenage pilots kept flying. They'd arrived in France as scared kids. Combat had transformed them into some of the most effective ground attack pilots in aviation history. They'd mastered a weapon system that veteran instructors thought too complex for inexperienced pilots. But every legend has its darkest moment. and the HVAR's vulnerabilities would soon prove as deadly as enemy fire. Despite its devastating success, the HVAR system had vulnerabilities that cost lives in ways neither designers nor pilots had fully anticipated. The most persistent problem remained hung rockets. Despite improved release mechanisms, rockets occasionally failed to leave their rails when fired. The statistics were sobering. Approximately 2% of rockets hung during combat operations. With pilots firing hundreds of rockets daily across all squadrons, that meant multiple hung rocket incidents weekly. Lieutenant Thomas Bradley experienced this on September 15, 1944, during an attack near Aachen. He fired 2 rockets at a German truck convoy. The right rocket fired normally. The left rocket's motor ignited, but the rocket stayed locked in its rail. Bradley felt the aircraft yaw violently. At 1,200 feet altitude, he had perhaps 3 seconds to react. Training took over. He immediately released his remaining rockets, jettisoning them without firing to reduce weight, and used full rudder trim to counter the asymmetric thrust. The burning rocket motor exhausted after 1 second, but that second felt eternal. Bradley regained control at 400 feet, barely clearing a tree line. He landed safely, his P-47 scorched black where the rocket motor had burned. Ground crews found the release clip had been improperly installed. A mechanic's error nearly killed him. Accuracy remained frustratingly inconsistent. Even experienced pilots missed targets frequently. The problem was the weapon's complexity. Rockets followed ballistic trajectories affected by aircraft speed, altitude, dive angle, crosswinds, and the rocket motor's burn characteristics. Pilots had to unconsciously calculate all these variables while under fire, then execute the attack perfectly. Training simulations showed that under ideal conditions, experienced pilots hit point targets about 40% of the time. In combat, that dropped to 15–20%. Against large targets like convoys, hit rates were better, but individual rocket accuracy was poor. Pilots compensated by firing multiple rockets, accepting that most would miss. German countermeasures evolved rapidly. Anti-aircraft crews learned to concentrate fire on aircraft during the critical moments of rocket attacks, when the pilot was committed to steady, level flight for aiming. This was when P-47s were most vulnerable. Flak casualties increased steadily through late 1944. The Germans also dispersed vehicles more widely, positioned them near buildings or trees that made rocket attacks difficult, and moved primarily at night or during bad weather. These tactics reduced Allied effectiveness significantly. What had been turkey shoots in August became grimly dangerous missions by October. Weather posed challenges the designers hadn't fully considered. Rain affected the rocket motor's electrical igniters, causing misfires. Cold temperatures at high altitude sometimes froze the firing circuit. Moisture in the launch rails caused corrosion that could jam release mechanisms. Ground crews worked constantly maintaining the system, but combat conditions made perfect maintenance impossible. The human cost was mounting. The 365th Fighter Group lost 11 pilots in August, 14 in September, 17 in October. Not all were rocket-related casualties. Some died from flak, some from mechanical failures, some from pilot error. But the rockets contributed to the danger. Their weight reduced aircraft performance. Their complexity created more failure points. Their employment required flying low and steady through defensive fire. Young pilots bore this burden differently. Some became fatalistic, assuming they'd eventually be killed and focusing only on the present mission. Others developed superstitions, lucky charms, pre-flight rituals, anything to create an illusion of control. A few broke psychologically, unable to continue flying into deadly fire daily. Lieutenant Fletcher, now a veteran of 40 missions, described the cumulative stress. Every mission, you know this might be the day. The day your rocket hangs, or the flak finds you, or you make a mistake. You keep flying because your friends are counting on you, because the mission matters, because stopping means you've given up. Yet one mission would prove why this aircraft earned its place in history. A mission where a 19-year-old's mistake would become the most successful rocket attack of the war. March 17, 1945. The mission that would make 19-year-old Bobby Cowan a legend entirely by accident. The briefing at 700 hours was routine. Intelligence reported a German convoy moving south near Koblenz, attempting to evacuate supplies before American ground forces cut them off. 8 P-47s from the 365th would intercept. Cowan, with only 4 previous combat missions, was assigned as wingman to Captain James Mitchell, the most experienced pilot in the squadron. The formation took off at 900, flying northeast toward the Rhine. Weather was poor, low clouds, rain, typical March conditions. Visibility was marginal, making navigation difficult. German flak had diminished significantly by this stage of the war, but what remained was concentrated around key routes. At 14:25 hours, Mitchell spotted the convoy on the Autobahn near Koblenz. A substantial force, approximately 40 vehicles, stretched along 2 miles of highway. Trucks, half-tracks, several fuel tankers, and what appeared to be ammunition carriers. High-value targets. Mitchell's voice over the radio was calm, professional. "Tally-ho, convoy on the highway, 12 o'clock. Line abreast formation. I'll take the lead vehicles. Cowan, you're on the rear section. Remember, 2,000 feet, steady aim, fire on my mark." Cowan acknowledged, his voice tight with nervous tension. This would be his first attack on a major convoy. His previous missions had been against isolated vehicles or already destroyed targets. This was different. Real combat, real consequences. The flight split into pairs, positioning for coordinated attacks from different angles to prevent escape. Cowan followed Mitchell's P-47 as they climbed to 4,000 feet, then rolled into their attack run. Below, the German convoy continued moving, unaware of the threat above. Mitchell's countdown began, starting our run 3,000 feet, leveling at 2,000, steady now, wait for it. But here's where everything changed in an instant. Cowan's attention was split between following Mitchell, watching his altitude, monitoring for flak, and trying to remember his training. His hands gripped the control stick, slick with sweat inside his flight gloves. His thumb rested on the throttle, standard hand position. But his hand was shaking from adrenaline and tension. As they descended through 2,500 feet, Cowan unconsciously tensed his hand to steady it. His thumb, resting near the rocket release button, pressed down slightly. Just a fractional movement, not intentional. An involuntary muscle contraction from stress. The electrical circuit completed. All 8 rockets fired simultaneously. Cowan's first reaction was horror. He watched 8 white smoke trails streak away from his wings at 2,500 feet altitude, a full 1,000 feet too high, 3 full seconds before the proper release point. In those 3 seconds, his rockets would travel nearly 3,000 feet forward and drop hundreds of feet. They would miss the convoy entirely, impacting far beyond the target. Mitchell's voice, "Cowan, what the hell?" But Mitchell stopped mid-sentence, because something impossible was happening. The rockets, fired early and high, followed their ballistic trajectories. They arced through the air, descending. The convoy was moving forward at approximately 30 mph. In the 3 seconds between Cowan's accidental firing and the rocket's impact, the convoy traveled exactly 132 feet forward. The lead rocket struck a fuel tanker in the middle of the convoy. The tanker exploded in a massive fireball. The explosion engulfed the 2 vehicles immediately adjacent, another fuel tanker and an ammunition truck. Secondary explosions rippled through the convoy. Burning fuel spread across the highway. The ammunition truck's cargo detonated, hurling shrapnel in all directions. The result was catastrophic chain reaction. Vehicles attempting to escape crashed into burning wreckage. More fuel trucks exploded. Panicked drivers lost control. Within 15 seconds, the entire 2-mile convoy was either burning, exploding, or wrecked. Cowan, still expecting to see his rockets miss by a mile, watched in stunned disbelief as the entire convoy died. Mitchell's voice returned, now tinged with amazement. "Cowan, what? How did you?" "I don't know, sir," Cowan stammered. "I fired early, I pressed the button by mistake." Mitchell circled the devastation below, all 40 vehicles destroyed or disabled. German soldiers fleeing on foot, total destruction. As the war progressed, the HVAR would continue to evolve, but nothing would match the legendary story of the 19-year-old who destroyed an entire convoy completely by accident. By March 1945, warfare was changing rapidly, and Bobby Cowan's accidental success would ironically lead to a tactical innovation that changed rocket employment doctrine. After the Koblenz incident, squadron intelligence officers analyzed Cowan's attack in detail. The gun camera footage clearly showed the rockets firing at 2,500 feet, far higher than standard procedure. Yet the results were superior to textbook attacks. Why? Captain Mitchell recognized what had happened. Firing high and early allowed the rockets to follow longer, more ballistic trajectories. This gave them greater terminal velocity at impact. More importantly, it positioned the attacking aircraft outside the most lethal flak envelope. Standard attacks at 2,000 feet put pilots directly in the zone where German 20 and 37 anti-aircraft guns were most effective. The tactical implications were significant. If pilots could fire from higher altitude while maintaining accuracy, they could attack defended targets with reduced casualties. The trade-off was precision. Higher firing altitude meant less accuracy. But against large targets like convoys, the reduced accuracy was acceptable if it meant fewer pilots killed. Mitchell proposed revised tactics. Attack from 3,3500 feet, fire rockets early, accept reduced accuracy in exchange for improved survivability. The squadron commander initially resisted. This violated established doctrine. But the casualty statistics were undeniable. The 365th had lost 17 pilots in the previous month. Any tactic that reduced losses deserved consideration. Experimental missions were flown throughout late March. Pilots practiced high-altitude rocket attacks on practice ranges, developing new aiming techniques. The modified tactics proved effective. Hit rates decreased slightly, from 20% to about 15%, but pilot survival rates improved dramatically. Flak casualties dropped by nearly 40% in April. Other squadrons adopted the modified tactics. By April 1945, the Cowan method, though officially it was never called that, had become standard across rocket-armed fighter groups. The accidental discovery by a terrified teenager had inadvertently solved a problem that killed dozens of experienced pilots. Meanwhile, the HVAR system itself continued evolving. A new warhead design introduced in early 1945 improved armor penetration by 30%. Modified igniters reduced misfire rates. Improved launch rails virtually eliminated hung rocket problems. The weapon that had been dangerous and temperamental in 1944 was becoming reliable and refined. Production had reached enormous scale. Over 350,000 HVARs were manufactured by war's end. Every American fighter group in Europe carried them. The weapon had proven itself so effective that procurement officers ordered more rockets than aircraft could possibly employ. Storage depots overflowed with unused rockets. Different variants emerged for specialized roles. An incendiary warhead version proved effective against fuel storage facilities. A fragmentation warhead worked well against troops in the open. A delayed fuse version allowed rockets to penetrate buildings before detonating. The basic HVAR design was adapted to numerous tactical situations. The final major operations demonstrated the weapon's maturity. During the Rhine crossing in late March, rocket-armed fighters provided close air support that ground commanders called the most effective they'd experienced. Pilots could strike German positions within 200 yards of friendly forces, precision impossible with conventional bombs. Bobby Cowan flew 23 more missions after his famous accident. He never again achieved the spectacular results of March 17th, but he became a competent, professional pilot. His accidental success didn't make him an instant ace or tactical genius. It made him lucky. He understood that distinction and never pretended otherwise. By April 1945, as German resistance collapsed, rocket attacks became less frequent. Targets were scarce. The Luftwaffe was essentially destroyed. Ground forces were surrendering en masse. The weapon that had been essential 6 months earlier was now employed mainly against isolated pockets of resistance. The war in Europe was ending, but the weapon developed in desperate urgency would leave a lasting impact on tactical aviation. And then came the moment that would define its legacy, the end of war and the assessment of what this teenager's accident had revealed. When the war ended on May 8, 1945, Second Lieutenant Bobby Cowan was at an airbase in southern Germany, sitting on the wing of his P-47, watching other pilots celebrate. He'd flown 27 combat missions total. He'd destroyed 14 enemy vehicles. He'd survived when many hadn't, and he'd become accidentally famous for a mistake that military historians would study for decades. The final rocket missions occurred on May 7th, just hours before the surrender. The 365th Fighter Group flew one last sortie against German units refusing to acknowledge the ceasefire order. Lieutenant James Fletcher, the nervous kid from training who'd become a hardened veteran, fired the last HVAR rockets of the European war at a German convoy near Salzburg. The convoy surrendered immediately when the rockets impacted nearby. Nobody wanted to die on the war's final day. The statistics from 11 months of combat operations were staggering. Total HVARs fired in combat, approximately 230,000 enemy vehicles destroyed, over 15,000 confirmed German tanks destroyed by rockets, 2,400 plus American aircraft losses during rocket attacks, 342 pilots killed success rate, approximately 18% direct hits on point targets, 60% effectiveness against area targets like convoys. The kill ratio was unprecedented. A single pilot with 8 rockets could destroy more enemy armor than an entire tank battalion. The weapon had revolutionized ground attack aviation and proved that air power could decisively affect ground warfare. But here's what made the story truly significant. Bobby Cowan's accident had revealed a fundamental truth about weapons employment. Sometimes doctrine was wrong. Sometimes mistakes led to innovation. Sometimes a terrified teenager stumbling into success taught lessons that experienced officers had missed. The Cowan method, firing from higher altitude, accepting reduced accuracy for improved survivability, was formally incorporated into U.S. Air Force tactical manuals in 1946. The doctrine Cowan accidentally discovered saved lives in Korea 5 years later when rocket-armed F-51 Mustangs and F-80 jets used identical tactics. Cowan himself returned to Pennsylvania, finished college on the GI Bill, and became a high school mathematics teacher. He rarely spoke about his wartime service. When students discovered he was a decorated veteran and asked about his experiences, he'd deflect. "I flew airplanes. I did my job. I was lucky." He never mentioned the famous incident unless directly asked. In 1983, a military historian researching HVAR tactics discovered Cowan's story buried in squadron records. He contacted Cowan, now 58 years old, and asked for an interview. Cowan's response was characteristically modest. "I made a mistake. Physics and luck turned it into something useful. That's the only remarkable thing about it." The historian pressed, "But your accident changed tactical doctrine. Pilots trained on your technique. Lives were saved because of what you discovered." Cowan's response revealed his perspective. "I didn't discover anything. I was a scared kid who pressed the wrong button at the wrong time. The fact that it worked out well doesn't make it less of a mistake. The real heroes were the pilots who flew every day knowing the odds, who pressed attacks when every instinct screamed to pull out, who didn't come home. I'm not a hero. I'm a guy who got lucky once." The HVAR itself served in the Korean War, then gradually phased out as guided missiles replaced unguided rockets. A few survived in museums, inert training rounds displayed alongside the aircraft that carried them. The National Museum of the United States Air Force displays a P-47 with HVAR rails, a physical reminder of the weapon that changed ground attack warfare. Bobby Cowan died in 2003 at age 78. His obituary mentioned his wartime service in a single sentence. But in Air Force tactical training, his accidental discovery remains a case study in how innovation sometimes comes from unexpected sources. Looking back, this story was more than just a teenager's mistake. It was a lesson about youth, war, and the unpredictable nature of combat. Looking back, Bobby Cowan's story was more than just a teenager's fortunate mistake. It was a profound lesson about warfare, innovation, and the unpredictable nature of combat that military strategists continue studying today. The historical impact of the HVAR system extended far beyond World War II. The weapon proved that unguided rockets could be effective against ground targets when properly employed. This principle influenced decades of tactical aviation development. The Korean War F-51s, Vietnam-era F-4 Phantoms, and even modern A-10 Warthogs trace their rocket employment doctrine directly to HVAR tactics developed by teenagers over Germany in 1945. But Cowan's accidental success revealed something more profound. Rigid adherence to doctrine could be counterproductive. The proper rocket attack procedure, firing at exactly 2,000 feet after careful aim, was developed by experienced test pilots under ideal conditions. Combat was neither ideal nor predictable. Cowan's mistake demonstrated that unconventional approaches sometimes produced superior results. The military establishment initially struggled with this lesson. How do you incorporate accidents into training? How do you teach pilots to violate established procedures when appropriate? The answer eventually emerged: train pilots thoroughly in standard doctrine, then trust their judgment to adapt based on circumstances. This philosophy, rigid training followed by flexible employment, became fundamental to modern military aviation. The youth angle remains striking. 18 and 19-year-old pilots with minimal experience were given weapons capable of destroying entire convoys. They were expected to employ these weapons accurately while flying at 300 mph through defensive fire, making split-second decisions with fatal consequences. That this system worked, that these teenagers became effective combat pilots, says something profound about human adaptability under pressure. The cost was substantial. The 365th Fighter Group alone lost 47 pilots killed during rocket operations. Across all American fighter groups employing HVARs, approximately 850 pilots died in rocket-related missions. Each death represented a young man who'd barely lived, whose potential was extinguished in service to tactical objectives. The question remains, was the tactical advantage worth the human cost? Military historians debate this, but the veterans themselves rarely questioned it. They understood the stakes and accepted the risks. Cowan's story specifically illustrates warfare's fundamental unpredictability. Plans fail, equipment malfunctions, people make mistakes, yet sometimes those mistakes produce outcomes better than intended results. The military strategist's challenge is creating systems flexible enough to capitalize on beneficial accidents while minimizing catastrophic failures. The technological legacy was equally significant. The HVAR demonstrated that simple weapons, properly employed, could be devastatingly effective. This influenced Cold War weapons development philosophy. Not everything needed to be complex, guided, or expensive. Sometimes a simple, reliable, mass-produced weapon was more effective than a sophisticated alternative. Today, fewer than a dozen people remember Bobby Cowan personally. His students from 40 years of teaching might recall him as a quiet, modest man who rarely discussed his past. Military historians know him as a footnote in tactical aviation history, the teenager whose accident became doctrine. But his story endures because it captures something essential about warfare's human dimension. War places enormous responsibility on very young people. It demands they make life-and-death decisions with insufficient information, inadequate training, and no time for careful consideration. Sometimes they succeed through skill and training, sometimes through courage and determination, and sometimes, as Bobby Cowan proved, they succeed through sheer dumb luck. The final lesson is perhaps the most important. In war, outcomes matter more than intentions. Cowan didn't intend to revolutionize tactical doctrine. He didn't deliberately develop a superior attack method. He made a mistake that coincidentally produced excellent results. But the result, a destroyed convoy, refined tactics, saved lives, was what mattered to history. The HVAR and the young pilots who employed it represent a unique moment in military aviation, when rapid technological development, urgent operational necessity, and youthful audacity combined to create devastating tactical effectiveness. It was messy, dangerous, and improvised. It cost lives and resources, but it worked. Bobby Cowan's accidental success symbolizes this era perfectly. Imperfect, unintended, yet undeniably effective. So there you have it. The complete story of how a 19-year-old's mistake destroyed an entire German convoy and accidentally revolutionized tactical doctrine. Over 230,000 HVARs were fired in combat, destroying more than 15,000 enemy vehicles. The weapon transformed ground attack aviation, and a teenager's accidental trigger press revealed that sometimes the best tactics come from unexpected sources. Bobby Cowan flew 27 missions, survived the war, and spent 40 years teaching mathematics. He never considered himself a hero, just lucky. But his accidental discovery saved lives and changed how militaries think about tactical innovation. What impressed you most about this story? The unlikely success, the youth of these pilots, or the lesson that mistakes can lead to innovation? Let me know in the comments below. And if you want to see more incredible WWII stories that reveal the human side of history, subscribe and hit that notification bell. We're covering the personal stories behind the greatest conflict in history. Thanks for watching WWII Aviation, and I'll see you in the next one.